Hi, welcome back to Chem with Go. Today we're going to take a look at another example in determining the steric number of a simple molecular geometry. So let's take a look at a molecule like this, Nh3 Nitrogen Tri Hydride, or more commonly known as ammonia. Ammonia will have a central atom and other constituent atoms around it. So, and again, from the previous steric number video, you'll note that this nitrogen atom right here is our central atom. Again, usually it's the first atom that's in the formula, unless it happens to be hydrogen. So let's go ahead and put that in the middle, and let's draw the number of valence electrons around nitrogen. From your lecture, you should note that nitrogen has 5 valence electrons, so let's go ahead and put those in. And I'll go ahead and circle the lone pair right there so you know that it's not form bonds with those electrons. Now, since I have 3 hydrogens, this ends up being a pretty simple molecule to draw the Lewis structure of. We connect the hydrogens right here, and right here. And there we go. There's our simple Lewis dot diagram for ammonia. Now, let's figure out what the steric number of this molecule would be. Well, since we know that nitrogen is our central atom, let's count the bonding areas around it. Well, nitrogen has 3 bonding areas. 3 bonding areas. One right here, one right there, and one right here. Now, how many lone pairs would this have? Well, here's the lone pair right here. So it happens to have 1 lone pair. Now, taking a look at a combination of 3 bonding areas and 1 lone pair, let's go ahead and add those together. So the steric number becomes 4. Alright, so that's how to find the steric number of this molecule. Again, we count the bonding areas and the lone pairs, and we add the 2 together. Now, what would the shape of this molecule be? Just to give you guys a heads up, this happens to be Trigonal Pyramidal. And the reason why it's trigonal pyramidal is that one of these bonding areas from a tetrahedral structure becomes a lone pair, and that happens to be this lone pair right here. And that tends to push these guys, okay, a little bit further away from the lone pair. And the reason why is because there is no nucleus up here at the top. And because of that, the bond angle between these guys actually is less than the normal tetrahedral structure. Now, in the future video, we'll go ahead and talk about taking a look at what these 3-dimensional structures would be, what their names would be, what their bond angles would be, and so forth. But I just wanted to go over what the steric number of this molecule would be. Alright, we'll see you in the next video.